All right. Hello, everybody. Pedantic Skeptic here, and today we are going to start part 2 of the Cornerstone Church's Apologetics session on origins and evolution. So it's their Apologetics session 35. And so I hope that y'all are ready for this. Again, I tend to do blind reactions, so I don't know what I'm in for, I don't know what you're in for, and neither do you. So, we're gonna get this ball rolling. Let's do this. You would just think that, like, the intro would, like, then go into, like, something a little bit more put together than just an informal several people sitting around talking. And I'm not saying that there's anything wrong with oh, we're all just going to sit around here and talk, but like this kind of hypes it up to be like a little bit more formal than it actually ends up being.
Dear Heavenly Father, we just are looking forward to, Lord.
Oh boy. I wonder where we're going with this. There's an evolution on a projector on one side of the guy, and then on the other side, oh, he's wearing a very nice hoodie. Pretty nice looking. Anyway, and then on the right side, there's a whiteboard with just a bunch of stuff written on it and a timeline. It looks like there's something like creation, corruption, catastrophe. What does that say? Confusion, Exodus. I can't read the next. I don't know, something about 971. Divided King something. Christ X Cross. Okay.
Just learning about your creation, learning more about you. God, to just spend time in your presence in fellowship with our brothers. God, we just thank you for Matt's preparation. We thank you for the time that he spent. And God, we just pray that you would bless him as he just feeds us from your word and from everything that you poured into him tonight, Lord God. We just thank you for this time, and we ask you to bless it in Jesus' name.
Amen. All right, so we've been a little disjoint with some of the sessions, partly because of my travel schedule, but this is really a continuation of the Origins and Evolution series of classes. Just as a recap, for last time we walked through sort of the origins of the universe, right?
Did you walk through or did you stumble through it?
We talked about the Big Bang. We talked about the beginning of the universe and the theories around how old the universe is, how old and how things came about from the matter and energy at the singularity of the Big Bang. We talked about a number of different cosmological arguments. The Kalam cosmological argument, which is...
Just a heads up, if anybody hears something funny in the background of my video, I have my laminar flow hood on right now. It just kind of sounds like a fan blowing almost, or a motor running. Because I built it myself, it does make some noise, but it's nothing more than that.
It's a fairly basic but effective argument for the beginning of the universe. And we talked about some philosophical problems with the idea of infinity. We talked about...
They did. Remember, they did a lot of conflation of eternality with infinity, and I'm not going to go back through that again, but there is a difference.
What we call God time, or God not being temporally fixed in time, but being outside of time, and the author of time and space. And so we kind of went through sort of the idea of the big, right? So if you remember, one of the websites that I went to had this sort of size and scale of the universe thing.
Yes, and that was incredibly distracting but fun. This is a really long recap. I mean, one of the things with religion in general, it's very slow. Church services are almost an hour, sometimes longer, and, these people are sitting around for a full hour. Like, if I found it more interesting, maybe it would be okay. I mean, this is just, it is painful to sit here, and I'll probably sit here for, the first 15, 20 minutes of the video. I got some other shit I gotta get done, but, I don't mind sitting here for a little while working on this.
Where you could zoom out to larger and larger distances, but it also had the ability to zoom in to smaller and smaller things, getting down to cellular and molecular level, and looking kind of at all of the complexity in the small as well as the large. We talked about the fine-tuning argument and how our universe is exquisitely fine-tuned. We talked a little bit about the multiverse. And the idea that even if, which is the common argument against the fine-tuning argument, which is that our universe just happens to be the one that's fine-tuned out of the...
That is the more simplistic explanation, because it doesn't involve something as complex as a creator. Who emailed me? Deal with that later.
Infinite number of universes, but then that just moves the problem away from our universe into the universe-generating machine.
Again, moving this onto a creator only moves the problem to, well, who created the creator? Where did the creator come from?
It has to generate all these universes, and how exquisitely fine-tuned it would be. I threw up a formula that everyone in the room recognized, which was the formula for gravity, and talked about things like the cosmological constant, the gravitational constant, the strong and weak forces, and how each of these things has to be so exquisitely fine-tuned that if any one of them were different, either stronger or weaker, that the universe either would have collapsed in on itself at the Big Bang, or would have expanded so rapidly that it would have resulted in rapid heat death. And we even talked about some of the fine-tuning of our solar system. The fact that we have things like...
Just get on with it. Come on. I mean, this is on the internet for anybody to go see. You don't need to spend, 4 minutes recapping, your previous session. Jesus Christ.
Jupiter, right? A large gravitational body in our solar system that probably protects us from various asteroid strikes and things floating in, and the fact that our moon is tidally fixed, and just so many different things about our universe that really cries out at the creative power of our God, and the fact that that there is specialness, right, to his creation.
Define specialness.
That he...
it looks like I can skip past
it is
the
evident
recap.
that it is that there's somebody behind. There's someone,
Can I go to the
and we
next
talked
chapter?
about the attributes that designer would have to have. They would have to be timeless, spaceless, unimaginably powerful. So they it really speaks to there being a God behind. So now, that was like a whirlwind recap of kind of the discussion that we've had, around the origins of the universe. Now we're going to talk about the origins of life.
I don't see anything about the origins of life up there other than the creation thing. Evolution has nothing to do with the origin of life.
I'm going to start, though, a little bit past the origins of life.
Okay, that's good. So these people don't seem to be conflating abiogenesis and things like that with evolution. Give them that.
We're going to talk about what they call chemical evolution, which is
Oh boy, here we go. Here we go.
The origin of first life. But first, what we're going to talk about is evolution itself, and actually, I want to start with a question, which is, who here believes in evolution?
And I guess
Who here believes in evolution?
it's not really a belief so much as an acceptance of the scientific fact, but whatever. Just roll with it.
Anyone raise their hand? You should all be raising your hands. Every single one of you should be raising your hands. Everyone believes in evolution. The problem is the baggage that comes with that term. And so the very first thing that I wanted to bring up was...
Oh boy, let's see what this is. Let's just... Okay, place your guesses now. Is he gonna go into, like, racism? Is he gonna go into slavery? Is he going to go into, like, school shooters? Is he going to go into, segregation and things like... I mean, like, where is he going with this? Let's just see. Let's just see.
The definition.
Okay. So let's read through this, and let's just see. 1A. Descent with modification from pre-existing species. Cumulative inherited change in a population of organisms through time, leading to the appearance of new forms. That sounds more like speciation rather than evolution. Evolution is a process of continuous branching and diversification from common trunks. Evolution causes this, but that's not specifically evolution, if you really want to get down to it. The scientific theory explaining the appearance of new species and varieties through the action of various biological mechanisms such as natural selection, genetic mutation, or drift, and hybridization. Alright. I really should make a hybridization video. I'll do that after I make part 1 here, to their part 2. But, let's see, since 1950... developments in molecular biology have had a growing influence in the theory of evolution. Okay, not bad. In Darwinian evolution, the basic mechanism is mutation followed by selection of the organisms most likely to survive. Yeah. The historical development of a biological group. Not exactly. The process of change in a certain direction. Yeah, that's pretty close. The action or an instance of the forming and giving something off. What? That has nothing to do with evolution. Process of continuous change from a lower, simpler, or worse. What? No, 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 and no. We don't use terms like lower or higher, in science. Simpler or more complex. I guess that's okay. Evolution doesn't always favor the more complex. Evolution favors the best suited, and sometimes the best suited is actually the most energy efficient, which is usually more simplistic. The simpler an organism tends to be, the less energy it tends to need on average, and so in places where resources are scarce, you either become so complex that you're good enough at getting the resources you need to stay alive, or you're just too simple to really kill off. Better and worse, those words don't really have a meaning in science. Those are qualitative, not quantitative. So, let me give you an example. I'm doing an experiment right now on insects. And, I'm feeding them different diets. If I say one diet is better than another, that's not good enough for a scientific paper. The science paper wants to know, how am I measuring better, worse, whatever? Am I measuring the insect's mortality rate? In that case, I would say diet A resulted in a lower mortality rate than diet B. Am I measuring growth rate? The insects rooted on diet A grew more rapidly, put on weight more quickly. They reached their mature stage X number of days sooner. Something like that. Am I measuring fecundity? Females that were rooted on diet A laid 20% more eggs in their lifespan than females who are on diet B. Something like that. Not just better or worse. Those are not words that belong in science. Okay? It's not science. A process of gradual and relatively peaceful social, political, and economic advance. That's not biological evolution. Something evolves, no shit. The process of working out or developing. Evolution is simply the change in gene frequency in a population over successive generations. Okay? That's all it is. It causes a lot of these other things, but that itself is not evolution. Okay? Just like, sex can lead to a baby, but a baby is not sex.
Of evolution, because this is indicative of the sort of cultural context that we live in, where you actually hear the term evolution, and every single one of you immediately thought of Darwinian evolution by natural selection and random mutation.
That is because that's what you're going to be talking about, but, if you, I feel like this is going to be a bait and switch type of thing, because you're going to define evolution at the beginning here as one thing, and then you're going to say, well, now you're going to use evolution in a different way, without really specifying that you're actually talking about a different type of evolution. Let's hope he doesn't do this, but I have a feeling it's going to be some shit like that.
Every single one of you probably didn't think those words necessarily exactly, but that's what you were thinking of when you heard the term evolution. And so I decided to first start with the Merriam-Webster's definition of evolution. And so the very first thing...
Just a heads up, the people who write dictionaries are not scientists always. I mean, there might be some scientists who are writing, but these are linguists. These are people who know more about language and how it's used than they do about biology. If you really are concerned about understanding evolution correctly, you would talk to a biologist, not consult a dictionary, okay?
Thing that shows up, definition 1A, is descent with modification from pre-existent species. Cumulative inherited change in a population of organisms through time, leading to the appearance of new forms, the process which new species or populations...
I just want to know what, why is, the word forms even here? I mean, I'm not sure what forms means. Now, if you said varieties, subspecies, things like that, and let's put aside the biological species concept for just a hot minute, because that itself is, like everything else in biology, not simple. Okay? Biological species concept is a really tricky thing to navigate. We're not going to worry about that right now. We're going to start at the ground level, and we're going to just gradually climb the ladder of our understanding of this. Now, descent with modification from pre-existing species, cumulative inherited change through time, leading to the appearance of new forms. So I'm not entirely sure what he means by new forms. That's a really wishy-washy word.
Of living things developed from pre-existing forms through successive generations. And then it has a quote from Stephen Jay Gould, which I won't read. It then says, also, the scientific theory explaining the appearance of new species and varieties through the action of various biological mechanisms such as natural selection, genetic mutation, or drift, and hybridization. Another quote.
I'm just noticing, it says this pattern, the second definition, the pattern of irreversible separation. That's not entirely true. We will talk about that later.
Actually, two quotes. And then B of that is the historical development of a biological group, such as a species or phylogeny. I can't pronounce it. Never mind.
It seems like he's never heard of these concepts before. He really shouldn't be trying to tackle something that he has no understanding of.
2A, the process of change in a certain direction, unfolding. 2B, the action or instance of forming and giving something off, or emission.
I guess. I mean, like, in chemistry, they say, like, this evolved a, substrate, sorry, not substrate, I'm trying to think of the word, this evolved a, I think it starts with an S. It's like the result of the chemical reaction that has become a separate state now. Like, if you dissolve some iron compounds, for example, you can dissolve in water. But if you react them with like an acid, precipitates. You precipitate out something that's no longer soluble in water. So you could say the precipitate evolved out of that reaction. Not the same thing.
C, a process of continuous change from a lower, simpler, or worse
That guy's got to do something about his cough.
to higher, more complex, or better state, growth. 2, a process of gradual and relatively peaceful social and political and economic advance. 3,
Really?
definition 3, the process of working out or developing. So it took us all the way to definition 3 to get.
That coughing is really concerning to me. I mean, I know that these aren't the people that are as concerned about COVID and things like that, but, like, do you have to, like, one, you're, like, fucking up the audio of the video, but also, you're putting other people at risk of getting sick from you if you're sick. I mean, something's wrong with you. I don't know if it's contagious, but something's wrong with you. You might want to go, like, rest at home and see a doctor.
At what evolution itself actually is, which is the process of working out or developing. It's just change over time. That's all evolution is. And it's obvious that change over time happens.
Yes. You know, a lot of creationists object to, like, the speciation concept and things like that. To the point where they don't even want to use the word species a lot of times.
The problem is that, and it's evident by the order in which these definitions occur, and by the fact that each and every one of you thought the same thing when I asked if you believed in evolution.
Let me guess. He's going to be talking about, like, society is training us to think about this when you hear the word evolution. I mean, like, in a way, I don't know if it's societal. I think it's more just the word evolution, while it has other colloquial meanings, is generally only used in a biological context. We don't generally use the word evolution to describe other types of changes. And while it's not grammatically incorrect to do that, we just don't. I mean, there are plenty of grammatically correct ways of phrasing things, and there are plenty of words whose definitions are very similar. Like, here, look. Let's go to a thesaurus. Okay. Come on, load, you motherfucker. Let's just click the word experience. I mean, I can see most of these words being used. Let's click another word. Difficulty. Okay. Here we go. So, the word difficulty has several synonyms, such as adversity, predicament, complication, snag, crisis, struggle, deadlock, trouble, dilemma, frustration, hardship, hazard, obstacle, pain. arduousness, barricade, some of these things. Oh, I guess like the darkest colors are the closest synonyms, and then as you get away from that color, but how many times does somebody use the word exigency? I mean, I might say exigent circumstances, perplexity, quagmire, and we're not talking about Family Guy, snag, deadlock. Some of these words would be perfectly fine words to use to describe a difficulty or a challenge. However, I wonder why challenge isn't on there. Anyway, strenuousness, tribulation. These are technically correct words to utilize for, describing a difficulty, but some of these are almost never said by everyday people. Hitch and impasse, hindrance, paradox, quandary. Some of these things, while they are technically correct words, or like mental burden, maybe this has challenge on it. No, but argument, it depends on the usage of the word, but, there are a lot of ways to say the same thing in our typical everyday, conversations. And we don't use all of these technically correct ways of describing things. The hell? Yeah. So you gotta stop with the well, this is what we hear all the time. Yes, there are some words that, while they have other definitions, primarily are used to refer to something. And sometimes people have a more advanced vocabulary, so they will utilize other words. But the other thing, I just said utilize instead of use. Could I have said use? Yes, but I said utilize. I don't hear a lot of people say utilize unless, we're talking about something scientific, but, it is what it is.
That our culture has ingrained evolution in everyone's mind.
I mean, it's not a culture thing. I mean, it is a hot topic, but, just because other meanings of the word evolution, exist, doesn't mean that people are going to use the word evolution to describe those things.
Darwinian evolution by natural selection. So the very first definition on here was the Darwinian evolution by natural selection.
Sort of. I mean, that 1A doesn't specifically get at natural selection, it just gets at the appearance of new forms because of inherited change.
Definition. And it just brings me back to a lot of the man on the street interviews that I watch for fun.
We all have our things to do for fun. But I do have to say, again, a lot of these people are, they almost act like you have to understand everything about evolution or you must accept creationism. And if you don't accept creationism, you're supposed to know everything there is to know about evolution. One, people can reject both creationism and evolution. And two, not everybody studies evolution to the point where they can answer all of the questions you bombard them with. Not everybody has time. Walking around on the street, if somebody like this guy came up to me and wanted to talk to me about evolution, I probably would not take time. Especially right now where it's 20 degrees outside, if you're seeing me walking around outside, I'm probably trying to get somewhere that's inside. So don't stop me and don't interrupt me when I'm trying to walk somewhere. But, if you're really curious about it, if you genuinely want your questions answered, talk to somebody who specializes in that field.
Where you could walk down the street, ask any high school kid, any college kid, any random person on the beach in California or Florida or anywhere, what is evolution, and they could tell you.
I don't know if that's true. I'm willing to bet not anyone can tell you. A lot of people could, but not any random person. I mean, and we'll exclude, like, babies and toddlers, but, I think that you're, getting a little bit, off track, because you want to address evolution itself, and you're not making the point you think you're making by saying that, most random strangers you survey will have at least some knowledge of what evolution is. Okay? That's not the same thing as having a good understanding and having, the ability to answer your questions about evolution.
I mean, they couldn't give you a really scientific definition, but they could tell you basically.
Yeah. That's because evolution isn't taught very well in high school. You don't really get to understanding the process until you hit college, and not everybody goes to college.
Basically what evolution was. But you ask him who the vice president is, or the Speaker of the House, or when our country was, when the Revolutionary War was, when our country was founded, and they probably couldn't tell you. They couldn't.
Some of those I could answer. Some of those I don't remember from middle school. I mean, like, if I studied history, maybe. Yeah, I don't know. I feel like this isn't the point he's trying to make. Because evolution has a scope beyond just a couple of events in U.S. history. Okay? Evolution applies to other parts of our lives, like whether or not we need to get vaccinated, whether, we have to worry about certain diseases, whether we have to worry about, our dogs and how they may have developed certain traits that aren't helpful to them, things like that. Whereas, the day that the U.S. was founded is a bit more arbitrary.
Tell you who we fought in World War II or why, but they could tell you whatever.
I do feel like it's important to know about World War II, especially given some of the reasons for World War II happening. But again, the American-centric, aspect of, like, the U.S. went into the war because of Pearl Harbor and we were pissed off at Japan, and then we eventually went over and fought in Germany too. I don't know all the details, but, that's kind of the gist of it. It's good enough for, like, a rudimentary explanation, I think, but that part is not the key point. The key point about World War II is that serious human rights violations were committed by a regime, and, other people were like, this isn't right, we need to stop this, and that's why the war was, really, fought. But, he wants to point out a couple of, fairly specific things. I would not say, like, if I were to make a list of, 100 things everybody should know by the time they graduate high school, the exact day the Declaration of Independence was signed is not going to end up on that list. I'd probably put on that list, like, what qualifies as a living organism, what processes dictate, how organisms interact with each other, what are signs that somebody is, having a mental health crisis, a lot of biological things because we're inherently biological. What chemicals, should you not mix when you're cleaning your fucking house? How do you change a tire? How do you file taxes? Just a mix of things that are going to be, pretty important for people to function in society. And the exact day that the Constitution was signed or whatever is not really something that should be on there. It's not something that's so critical to the well-being of a person.
Evolution is, and that's kind of indicative of how ingrained into our culture evolution is. It is, and I'm going to say this with air quotes.
Oh boy, is he going to say it's a religion?
It is a fact, right? If you ask anyone, any secular person, evolution is a fact. It is not a theory.
Yes, because all evolution technically is the change of allele or gene frequencies in populations over time. And that happens no matter what. You know, if I, light a forest on fire, the population of trees is going to have a change in the frequencies of different alleles. Unless, the fire somehow manages to kill, the exact same number of trees with genotype A, B, C, whatever, it's probably not going to happen.
When in fact, if you ask them why they believe it, they couldn't tell you.
It's not so much a belief as an acceptance of the fact. And the reason why I accept the fact of evolution is because not only have I observed it in real time with just some of my own adventures in like growing plants and rearing insects and other things, like when I bred my axolotls for the first time, I had a certain ratio of like one color morph to another, and then once my female laid a clutch of eggs and the eggs developed, suddenly I had not only additional color morphs of the axolotls, which means different genes are expressed, and I mean, it's a little more complex than that because, each gene has its own alleles, but we won't worry too much about that. But, the proportion of, like, allele A to allele B for every gene possible definitely changed during that process. Because even though, like, the Punnett squares have a certain distribution of, genes and alleles and where they should go and how, life doesn't match up 100% perfectly to that. You can get an odd number of things born, so of course you're not going to have the exact thing you predicted on the Punnett square. And I know I'm sounding a little nitty-gritty there, but really all it is a change in the frequency at which you see certain alleles. And that happens for a number of reasons. Part of it is that, you have an animal like an axolotl that easily, lays 300 to 800 eggs in one sitting, after mating. There are going to be some gene combinations that are not compatible with life. Now you've killed off a few of those embryos. And so that's going to muddy the waters. That's going to get rid of some of those alleles. There's going to be differential survival after they hatch, okay, for various reasons. And so you're going to have changes just by that happening.
They would tell you that it's because their teachers told them, or that's what science says, or scientists
Although you're going on the Bible just because the Bible tells you so.
say, but they couldn't really tell you much about evolution or why they believe in evolution.
Couple of thoughts. First of all, most people, I'm willing to bet, don't want to sit around and talk to you. Not that you're a bad person, but, we have a very busy culture. Whether or not that's good for us, that's a different matter. But, do you really think the average person wants to stand around when you've interrupted whatever they were already doing to chat with them about something like evolution? Generally, if you're doing that, you have an agenda in the first place. And some people just don't want to get involved with that kind of crap. Some people don't want to engage. You have to consider that. And also, people are stupid very often. Humans are smart, people are stupid. But, there are people who are just not prepared to have that kind of conversation with you. It's not that I don't like talking to strangers, but, generally when I encounter strangers, I'm not in the mood to stand around and chat. They're, if you, and, you're perfectly welcome, whoever this person making this video that I'm responding to, if you want to leave a comment on my video, and we can figure out, a specific time to schedule us to chat about this, that is one thing. If you come up to me while I'm in the middle of doing whatever I'm doing and want to chat with me, we're going to have a problem. Because, it's not even a matter of me whether or not I have my A game with me. It's a matter of, am I in the mood to engage with you? Sometimes people will just say things to see you off. They'll be like, yeah, I don't really think about it that much, blah, blah, blah. Even if it's something that they do think about a lot, because they don't want to have an hour-long conversation with you at that time. And that's their prerogative. You can't just force somebody to stand there and have a conversation with you if that's not what they want to do. And chances are, if you're going out in public, you're interrupting somebody's day to ask them these questions, and they want to get you off their back. That's what it is. Okay?
And this is, again, one of the reasons why we have this apologetic series, is because ask most Christians why they believe in Christianity, and a lot of them couldn't tell you either. And that's one of the sad things about the church in the United States today.
Is what? That people don't know how to answer that question?
So that's the fact that this is in the dictionary in this order just tells you that the priority to evolution is evolution.
I mean, if that's all evolution, there's not really a priority to any one thing, right?
By natural selection through random mutation. And let's dissect those words. So Darwinian evolution, it's called Darwinian because of Charles Darwin, who was the one who proposed the theory. And evolution.
Just a fun fact. Forgetting the guy's name, Alfred Russel Wallace. Basically, very close to the time Darwin did his evolution, independently came up with the same ideas. I think it was Alfred Russel Wallace. 1 second. Look at that beard. Yeah. Okay, if that's the way people are typing out their sentences these days. Okay. He'd lived a very long time for those days. Jesus Christ. Alright. Where were we? Oh boy. Oh boy. Okay. We're in for a treat, folks. So, it's not just Darwin. I personally like Wallace a little bit better just because he was really, focused on, like, bird-winged butterflies and things like that. Stuff that I would be interested in. Which, by the way, the bird wings are a really good example of, like, how ring species and species complexes work, which I'll make an independent video on later. But, the, thing about, the theory of evolution is it's not just natural selection, but, we'll get there.
In its original term, which has changed over time, by natural selection and random mutation. So
my question is, are they going to attack the theory of evolution as it first came out? Because any theory in science, the first people that came up with it, that had the first ideas about it, are obviously not going to be accurate. Because it's the start, it's the seed of, later inquiry and future investigation that, gets us to our current understanding. If you want to attack evolution, you want to attack the current, most recent, aspects of the theory. And, I don't want to say that they're not because they can't, but it almost seems like they just don't have that ability.
So natural selection just means that evolution is directional in that.
Oh boy. Just a second. Sorry, I just remembered I had a whole cup of waxworm moths that I have to take care of later. ADHD and the semester starting, it's just not a good mix. Anyway, what was he saying?
It utilizes mutations that work.
Utilizes mutations that work. It depends on what you mean by work, but yes, in a sense. If there is a mutation in the genome, that does something like, I don't know, synthesizes a protein that helps to reflect extra UV away from an organism's, cuticle, its outer layer, and so the organism is less prone to mutations that are bad or less prone to desiccation. That's going to be useful.
Right. So the idea of natural selection is that that repeated random mutations are attempted, and whichever random mutations work or benefit the organism are kept.
That is not entirely true, because mutations can be neutral and they can get passed on because they don't do anything. And, that is another way. I mean, like, technically nothing does nothing, but it doesn't change the coding of proteins because it occurs like in a non-coding section of the DNA. Or, here, I'll demonstrate this. Codon wheel. I fucking love the codon wheel. Okay, so let me just explain this. Actually, I want to find a clearer image that I can really blow up for you peeps. Can I enlarge this? Okay, that'll do for now. So here's how this works. DNA has 4 main bases. There are, I think, like 12 actual DNA and RNA bases. I'm gonna start with a very simplistic explanation, and if he starts getting into the explanation, I will become a little bit more complex about it. But in a nutshell, DNA, the DNA code, if you want to call it a code, it's more of just a DNA sequence. It's just an arrangement of one of 4 major bases, and they are on the DNA strand, and they basically call for certain chemicals called amino acids. They basically attract certain amino acids that stick to one another to build a protein. So you can have a strand of DNA that has various letters of a certain combination of bases that then causes a certain combination of amino acids to come together, which eventually gets you a protein. It's not that simple, but that's basically how it works. Now, well, not really a problem, but the thing is, each amino acid needs 3 different bases or 3 bases together to pull it to the protein. And what happens is, it's called a codon, where basically you have, since you have 4 main bases, this is uracil, in DNA it's thymine, but we're not going to worry too much about that. Basically, this is just the inverse of what the DNA strand was. Not going to worry about that too much yet, but a codon is 3 different bases in a combination. And that calls a specific amino acid. The problem is, because it's a group of 3, and there are 4 possibilities for each step along the way, you have 64 possible codons that can exist, but you only have 20 amino acids. And so, let's say your first part of your codon is guanine, G. If the first letter in the codon is guanine, if the first base in the codon is guanine, these are the amino acids you can attract. You can attract valine, alanine, aspartic acid, glutamic acid, or glycine. And you have some amino acids like leucine, where it can be a uracil/thymine or a cytosine to attract it, or to call it. But you know, so you can have I think some of these, like for uracil, if you have a uracil and then a cysteine after the uracil, no matter what that third codon is, it's a serine. Or you have your glycine, sorry, not glycine, is it glycine? Guanine. Your guanine, your next guanine, the only thing that can come after that is glycine, so it doesn't matter what that last part of the codon is. Same thing for alanine here, or valine, some of these things, like, some of these, like methionine, you have this, the AUG. It looks like is that the only thing that can give you methionine? Looks like it. But anyway, so if you have a mutation on the coding section of the DNA, so the DNA of GCG would be CGC. But if that last codon there gets changed to, if that last piece of the DNA gets switched out for like an A or a T or a C or something, it's not going to make any fucking difference, because it's still going to give you alanine. So the protein structure is still going to be the same, because the same amino acid is called for. It's just called for in a different way. It's kind of like, if you want to get a hold of me, you can text me, or you can email me, or you can call me. Well, don't call me because I'm not going to pick up the fucking phone. Or you can send me a message on Snapchat or whatever. You're doing it a different way, but you're still getting the same end result. Now, sometimes mutations can be neutral because the amino acid that's called for is close enough to the structure to the structure of the initial intended amino acid. So that would kind of be like texting my sister trying to get a hold of me, then my sister texts me to get a hold of you. I don't know all the structures of the amino acids, but basically protein structure is largely determined by the exact structure of the amino acid, because the amino acids differ a little bit in like how magnetic or how large or what shape they are. But if two of them are close enough in their initial like structure, they're not going to change that protein enough to make a difference. And again, like I already said, neutral mutations can occur when you have a mutation occur in the non-coding portion of the DNA. Now, if you really want to get technical, there could be an advantage to a mutation that, doesn't change the amino acid called for. For example, if you use a base that's more heat resistant, like some of those thermophilic bacteria, you're not going to be as susceptible to damage to your DNA, and you're still going to code for the same protein. Additionally, because a lot of viruses that insert their DNA into your DNA, or they insert their RNA into your cells, rely on particular strands of your DNA, if you make that code look different, the virus has a harder time infecting you. And so those are potential benefits to seemingly neutral mutations. But anyway, so there are mutations that can cause harm because they stop a protein from being formed, and if that protein is important enough, the organism can't survive. But in general, because, actually, let's just see here. God damn it, where's the codon wheel? Get off of that, get off of that, get off of that. There we go. We could do a calculation right now. Here. So what we want to do is we want to first calculate the probability that a mutation in the first letter, a change of the first letter, is going to cause a change at the end. Now this is going to be very convoluted, but I'm getting somewhere. So let's just, so this is going to be very binary, but let's just assume that if it causes a change at the end, it's going to be a harmful change. Not necessarily, but let's just pretend for this demonstration. So, if the initial part of the codon is a G, the chances that it'll change to a U are going to be 33%. The chances that it changes to a C are going to be 33%. The chances that it changes to an A are going to be 33%. Okay. So the chances of that change happening are 33%. So 0.33. Just trying to see, no, actually, I'm screwing this up. I don't know what I'm trying to get at. Because, for example, I'm trying to get at the chances that a mutation anywhere along this is going to cause a different amino acid to be called. But, like you have, like, arginine, you can start with a C or an A. Yeah, we'll come back to this because, I'm blanking a little bit about, I gotta approach it a different way. There are, no, I know how we do this. Hang on. So, how's up to 0.33? How many ways can we get glycine? It's like 4. Any other glycine? No. So 4 out of 64. How many ways can I get glutamic acid? Looks like 2 out of 64. How many ways can we get aspartic acid? Again, 2 out of 64. How many ways can we get alanine? Is it just 4? Yeah, 4. How many ways can we get valine? Again, 4 out of 64. How about arginine? 6. Yeah, 6 out of 64. Serine. Another 6 out of 64. How about asparagine? Let's see. Looks like a 2. Sorry, I skipped lysine. I'll get back to that. Asparagine. 2 out of 64. Lysine. It looks like it's just 2. Let me just double check. Yes. Lysine is 2 out of 64. We already got asparagine. Threonine. I think it's just going to be 4. Yeah. 4 out of 64. Methionine is just 1 out of 64. Isoleucine. I think it's just going to be 3 out of 64, but let me just double check. Yeah. 3 out of 64. We already got arginine. Glutamine. 2 out of 64. 2 out of 64. Histidine is also 2 out of 64. Proline. Looks like it's just 4 out of 64. Leucine. Didn't we just do leucine? No. 6 out of 64. Tryptophan is going to be 1 out of 64. Stop codon, which truncates the protein, is 1 out of 64. Cysteine is 2 out of 60. Oh, sorry, it's 3 out of 64 for the stop codon. 2 out of 64 for cysteine. Tyrosine looks like it's 2 out of 64. We already got serine. We already got leucine. And then phenylalanine is 2 out of 64. Okay. So, basically, what I've just done is I've gotten the probability. So the probability that you're going to code for an amino acid in the first place is going to be 61 out of 64 because 3 are going to give you the stop codon. Okay? Right? Right. Okay. So what you got to do is, this is how probabilities work. And I'm not going to go through the whole calculation right now because I just don't have time. But what you would have to do is first, you get the probability that something that is intended to be a stop codon actually gets changed to a an amino acid. You have to add that to the probability that something that is an amino acid gets changed to the stop codon. Then you got to go through and get all the probabilities that, something destined to be glycine is actually going to not be glycine, and do that for all 20 amino acids. You got to add up all those probabilities to then determine the probability that a mutation is going to cause a change in what the codons code for. Okay? And once you get all of those probabilities, that is your probability that a mutation will cause a change. Now, that's not the probability that that change will be harmful, and that's not even the probability that the tertiary structure of the protein will be different. That's just the probability that the amino acid sequence will be different. So that's where I'm going to end it for now. Wow, I've been going on for over an hour now. Okay, so I went on a bit of a ramble. I had not intended to go on for that long. I have some stuff I got to do. So what I'm going to do, I'm going to do that stuff. And then when I'm done with said stuff, I got to do some tissue culture. I should feed some mantises and clean my gecko cages. But I should probably, I'll just kind of intersperse everything. But I got to take care of some stuff. Then I'll come back, upload this to YouTube and stuff, and maybe start on part 2. But yeah, that was an interesting start to their thing. Just remember that everybody wants to paint mutations as inherently bad. A mutation just means a change to a genetic code. And because it's changed in the genetic code and not the amino acid sequence, more than likely that is going to be different. It's going to be harmless. It's not going to do anything. And so, just kind of take things with a grain of salt, okay? Because I'm just trying to remember probabilities. Yeah. Don't worry too much about it. We will cover more of this later. But yeah, thanks for getting to the end of this. And this is painful.